Radio TV phono nut here, and we have a Crosley Cathedral radio, probably from the early 30s, 32, 33 or so. Now this cabinet design is fairly common, but with an AC operated chassis paired with it. This particular model here is a battery operated set, and as you can see, it has the standard magnetic type pen drive speaker like what was common with battery operated sets from the time. I see 3 terminals on the speaker, so that tells us that most likely this is a push-pull output stage with a center tapped coil on the speaker. No audio output transformer. This is a high impedance speaker that connects directly between B plus and the plates of the output tube. A 5-tube chassis here. There is a model number plate on the back of the chassis, but I can't make it out. I'm going to have to unscrew the plate and put it under my magnifier to read it. This radio requires 2 volts for the tube filaments. It requires negative 22 volts for the C bias voltage, and it requires 135 volts and 67.5 volts for the B plus voltage. And the battery cable actually looks to be in pretty good shape, unlike most of these, and it still has the little tag things on it to designate which wire is which. I wouldn't be surprised if this radio, if we applied juice to it, I wouldn't be surprised if it played to some degree, unless someone has jack wired it and sent B plus voltage through the tube filaments and blew all them out, which I've seen before. Alright, let's get the chassis out of here and see what it looks like. Okay, here's a better look at the speaker. This is probably not a push-pull thing. It just looks like the 3rd wire just simply grounds to the speaker frame. So the first thing we want to do is take our ohm meter and measure across the speaker coil there and make sure it has continuity. If it doesn't have continuity, we can substitute this for a PM speaker, but we will have to place an audio output transformer between the output tube and the speaker, but hopefully we won't have to do that, because I would like to keep the original speaker if possible. This has so much more class than a modern day speaker from China. I'm reading 670 ohms across the speaker coil, so that's a very good sign. Now let's look under the chassis and see if there's any obvious butchering that's been going on, and then we're going to kind of clean this up a little bit and then begin the repair process, which I don't think will be too difficult. Here's the underside of the chassis, and this looks pretty good. In fact, this may have never been touched before. Like so many of these battery radios, they were only used for a short period of time until the customer received AC power, and then at that point the battery radio was put into storage and forgot about for decades. So in other words, a lot of these types of sets weren't in use long enough to really give trouble. So there you go. And the ones that were in use were used sparingly because they wanted to make that battery last as long as possible. I remember a friend who grew up during the World War II era telling me that they lived on a farm and all they had was a battery radio, but during the war it was very hard to get radio batteries, and he said the only time we were allowed to turn the radio on was for about 10 or 15 minutes in the afternoon to get the war news, and then the radio was switched off. And he said it wouldn't have done for my father to come in and catch one of us with the radio on listening to music or whatever. He said we would have gotten in serious trouble. You know, today we just take stuff like that for granted, but there was a time when, you know, it was a lot harder to get things and such. Although with everything going the way it is today, with the economy and the idiots in Washington doing things the way they're doing, I think we're starting to get a taste of that again. Here's a tung-sole tube that looks to be the audio output tube, type 33, with a sticker on it with a handwritten date of possibly July the 6th, 1933. Okay, I've very carefully cleaned this tube off. I cleaned around the sticker and the ID number here is not to damage those. So we'll do the chassis the same way and the rest of the tubes the same way. This is not going to be too involved here. This thing's in actually pretty good shape. Alright, here we are all cleaned up. All of the tubes are Sylvania brand for the exception of that one tung soil tube. Now I need to remove the model plate so I can magnify it and see if I can determine what model number this set is. Possibly 278, but even under the magnifier that's hard to make out. It's so faded, but it's something 78 I believe, so it should be only a matter of just going through Nostalgia Air and finding a Crosley that matches the tube complement of this set. So we're going to do that right now. Well, isn't this nice? Now I guess Nostalgia Air is not going to work. Well, I found out it's a model 78, but I still can't get to Nostalgia Air. This is one reason right here why I advocate keeping printed volumes of Riders and Photofax and Beatman's most often needed schematics for just for stuff just such as this. Okay, correction, it's actually a model 178. Okay, I just checked and the power switch appears to be open, which seems to be a fairly common occurrence with switches this old that haven't had any juice applied to them in decades. The contacts get dirty. Usually if I can get some contact cleaner up in there and work them back and forth a bunch of times and then apply juice to them, they'll open up. Well, actually already opened up. They'll close up and make contact. Okay, I was just able to spray some contact cleaner up through the little rivet hole there. And now we're going to work it back and forth a bunch of times and hopefully it'll make connection. Alright, we're getting better. Up in the meg ohms before I cleaned it. After I cleaned it and flipped it back and forth a jillion times, we're down to like 30 something ohms now, so we're getting there with it. I think this switch is probably salvageable. Okay, the resistance of this switch keeps bouncing around from a few hundred k ohms to over a meg ohm to under 100 ohms, so I think what we're probably going to have to do is pass some current through this and maybe it will cooperate. If not, we'll just have to jump her out the switch and whatever power supply we end up building to run this radio, we'll just have to use the switch on that if we have to. Alright, here's my pitiful looking power supply that I built umpteen years ago as a kit from Antique Electronics Supply. It provides variable filament voltage, a variable C bias supply, and then various B plus outputs from 22.5 all the way on up to 135, I believe. There was a potentiometer on here for adjusting the bias voltage, but I can't remember if I robbed it for something else or whether it broke and I never replaced it. But we can rig up something to get our 22 volts bias supply out of this. Unfortunately, Antique Electronics Supply does not offer this kit anymore. Actually, Antique Electronics Supply is not near the company they were before they sold out. It seems the new owners have basically turned it into a guitar site, whereas used to it was more dedicated to the repair and restoration of antique radios, TVs, record players, that sort of thing. I still order capacitors and such from them from time to time and such things as that, but stuff like tubes, they've gotten way out of sight on some of their tube prices, so rarely ever order any tubes from them anymore. All the old kits that they used to have, they pretty much discontinued all of those. One day what I plan to do with this is build it inside of a cabinet and add some metering capabilities and that sort of thing. There's also another battery eliminator that's available called the Antique Radio Battery Eliminator 3, or ARB3 for short. It's a very nicely done, professionally made power supply. I think it cost between $150 and $200. I don't remember what it was the last time I checked, but once again, given the professional build quality, that's actually not a bad price for one. And I've been threatening to order one because I have older 20s and early 30s radios that could benefit from such a thing. Alright, now let's check this thing out and make sure it still works. Okay, we're powered up. Let's check our B voltages. This should be, what is this, 22, 47, 67, 90, and 135. So what do we have? We have nothing. So what's wrong with it? What in the devil is wrong with it? Okay, maybe the plug wasn't making contact in my outlet. Let's see. Yeah, that's still not any better. Well, 2 volts. That's not hitting on anything. Nope, nope, nope. So what's up with this? So it looks like we're going to have to troubleshoot the power supply before we can troubleshoot the radio. But yeah, I need to get around to replacing the plugs in this power supply. I've been saying that for 10 years. They're kind of loose and don't make very good contact anymore. Okay, I've got 193 volts on the capacitor, which goes around to the thermistor here. And I have about the same amount of voltage on the other side of that, so that tells us the thermistor is okay. Well, this should be reading the ground, and it's not. Move over here, we have ground. Move over here, we have nothing. So this should be easy to solve. Well, that didn't help anything. I've still only got 10 volts where we're supposed to have 135. And I think I see the problem right here. That transistor leg is broken loose from all the time of me knocking it around down here. So I'm going to tack solder that back in place and hope our output returns. Oh wow, now we're up to 13 volts where it should be 135 and dropping, and the battery's about to die. Okay, while the battery... Okay, I need to stop saying okay every time I start a new video segment. But anyway, while the camera battery was charging, I took the liberty of repairing this power supply. I found another broken lead on a transistor here, and there were some poorly soldered connections here from where I'd been taking stuff loose and playing with it and all that sort of thing over the years. So I redid all of that, and we now have our voltage back here. As far as the C supply, I'll show you here. It's a simple one. We have our rectified DC coming in through a 4.7K resistor, and then a 47 microfarad 35 volt filter capacitor with a 22 volt Zener diode to give us a regulated 22 volts there. And then we have a potentiometer configured as a voltage divider, so we can set the C voltage to a lower voltage than 22 if need be. Well, I'd already mentioned I had robbed this pod, or it had broken, or I removed it. For some reason I removed it, and since we need 22 volts for this little application, I just didn't worry about replacing it right now. I believe it's a 50K ohm pot. And then I checked our filament supply, have it set for about 2.2 volts, and our B supply is working. So I hope it stays working, because when I'm ready to work on something, I don't need the equipment flaking out on me. I also took the liberty of putting connectors on this battery cable to make it easier to connect to whatever kind of power supply I end up connecting this to. And in order to do that, I had to clean all of the wiring. It was so corroded and ugly, there was no way solder was going to stick to it. So I sanded each wire down thoroughly to where we could see the nice shiny copper, and then soldered the wires to these connectors here. That'll make things much easier. I also took the liberty of removing each tube and checking the filament continuity, and fortunately all 5 tubes have a good filament, so that tells us that nobody jack wired the connections on this and burned out the tubes. Unfortunately, our switch is still flaky. You know, it'll read something different each time you switch it on, anywhere between like 60 something ohms up to several meg ohms. So I think for now we're going to have to jump that switch out, and then we will decide what we're going to do with the switch later once we get the radio to play. And if we can't fix the switch, then we may just have to install a switch on whatever power supply we use for this and leave it at that. Okay, in order to jumper this, I had to get the switch out anyway because this big honking capacitor was in my way, so I figured, what the heck, let's try and fix this. Well, with me heating the terminals on the back of the switch, our closed resistance for one set of contacts is 9.2 ohms. That's as good as we've got it so far. And the resistance on the other set of contacts, on the other contact, is flipping around between 6 and 8 ohms. Let's turn it back on and see what it is. Now we're up to 27 ohms. So I think what we're going to do now is put a light bulb in series with this switch, run some juice through it, and maybe that'll make it make permanent contact. Okay, I have the switch connected across my dim bulb tester, which is, of course, would normally create a short. So let's bring it up real slow. And you can see our bulb is coming to life here. I'm not going to hit it at full voltage yet because I don't know what the rating of this switch is, being a DC set. Off, on, off, on, off, on. Now let's do the other set of contacts. And here's the other set of contacts. And there we go. Off, on, off, on. Okay, now let's check the resistance now and see if we have a 0 ohm short across both contacts now. And we have 0 ohms across that contact. That's what we want. Let's flip it off and on a few times and make sure that remains. Yeah, as long as it reads like under 1 ohm, I'm okay with it. Whoop. Might still want to run a little more current through this. Alright, let's check the other set of contacts. Alright, that's pretty good. Off, on, off, on. Okay, that's pretty good, but I think we're going to run a little more current through here to try to improve things yet a little more. Okay. Let that sit a minute. Okay, I'll flip this off and on several more times. Well, it would help if I would cut the power on. But yeah, I've had to do this before on switches. Now, If you get a switch that seems to click okay and it feels okay, but it's not making connection, then most likely it's old dirty tarnished contacts inside the switch. And of course, the first thing you do is spray it with contact cleaner if you can get some down in there, and then put a load across the switch like I just did with a light bulb here, and flip it off and on several times, and the current flow through the switch and the arcing when turning the switch off and on will often help clean the crud off of the contacts. And okay, we have the radio connected to the power supply. All voltages verified what they should be. Let's turn it on and see what happens. Well, I heard a little static in the speaker there. But that's all I'm hearing. Okay, all voltages are pretty stable except our bias. Pull that down to about 18 volts, which that seems kind of excessive. Audio section's working. Doesn't appear that anything else is, though. And the way they control the volume here is varying the bias on the audio output tubes. Well, I can tell you this output tube coupling capacitor is leaky. We're on the grid side, which I think goes through this inductor here before it goes to the grid. We got, if we can get the meter to stay on there, about 12 volts there. So yeah, we need to cut that out and put something in between that to get rid of that. We don't need that kind of positive voltage on the control grid of that tube. Well, I just pulled the end out of the old capacitor there. Very high quality stuff. Okay, I have a capacitor temporarily tacked in. Still no action here. Let's see if the positive voltage has disappeared from the control grid of this tube here. It should have. Well, what happened? Well, that ain't making very good connection where I stuck it on there. Yep, that's more like it, 1.3 volts. Okay, I have the signal generator fired up. We're going to see if we can blow a 455 kilocycle signal through this. And that'll tell us a lot about what our problem is. Oh, nothing there. That's probably the RF amplifier. Nothing there. And nothing there. So it appears that none of these stages are working. Okay, the way this appears to go, RF amplifier, oscillator mixer, IF amplifier, detector and first audio tube, and audio output tube. And so far the only stage we can tell is working is the audio output, audio amplifier, first audio and audio output stage. Okay, we know that by placing the output of the signal generator onto the control grid of the IF amplifier tube that there is nothing. This IF amplifier stage is evidently not working, or else the detector stage is not working. So what I want to do at this point is take the signal tracer and connect it to the grid of the IF amplifier tube and see if we're getting anything up to this point here. If we are, we should be able to hear stations in the signal tracer as we tune across the dial. Okay, we have our RF probe here. Let's see what we got. Doesn't sound too promising, does it? Let me put the camera down and tune across the dial and see if I get anything. Okay, I'm not getting anything at any of these grid caps here. Alright, looking at the IF amplifier tube, I think this is the plate. And we have something there, 130 volts. This next pin should be the screen grid. And we have basically nothing there, 2 volts. It's not squat. And when checking from screen grid to ground, I'm reading like 4 or 5 megohms, so it's not like we have a shorted screen bypass capacitor that's loading everything down. Okay, if we look here, there's something inside of this insulating sleeving here. On this end we have 67 volts, which is obviously our 67 volt B plus line, and then it goes over here to this pin on the oscillator and mixer tube, which also connects to this big 1 microfarad bypass capacitor, and then the other end goes back to the screen grid of the IF amplifier tube and probably other places as well. And we have absolutely basically no voltage there, 2 volts. So I'm inclined to think there's a resistor inside of this sleeving that is probably open. I also have no screen voltage on the RF amplifier tube, and it all traces back to here. Okay, I don't know the value of that resistor. I'd have to go up and consult the schematic. But I have my resistance substitution box set to 220K, and I have that clipped across here, what I suspect to be an open resistor, and we're going to turn it on and see what happens. Alright, now let's see what kind of screen grid voltage we have here now. Okay, that's the plate. $18 volts. We need to go lower on that. Alright, I just cranked my resistance value down, and that sounds more promising. What do we have on the screen grid now? 40 volts. Alright, let's tune and see if I hear anything. Yes, we do.
Even if it's one time in 5 years. So I don't see how you can lose your salvation if you have 1-3 cent, which is counterintuitive of the same.
That speaker sounds like garbage.
You know, the Bible teaches we're saved to a none, but it teaches that it's conditional, Terry. Salvation by grace is conditioned. For sweetness, but the beast offender appears to me. So don't let your dog near chewing gum. And then, in addition.
So this is what I had to do to get us to this point. First, we had to persuade the power switch to work, and then we found that the audio coupling capacitor between the plate of the first audio and the grid of the audio output tube was very leaky. That's no surprise. We replaced that, and then we found out that our screen grid dropping resistor that's located inside of this sleeving under here was wide open. Probably some kind of flex ohm resistor, and those are bad about opening up too. So once we did those 3 things, that got the radio to working.
restrooms and the nest is not in danger, leave them alone.
Now, in order for it to fully work properly, this would need to be recapped and any out of tolerance resistors replaced, and
that was your Animals Today Minute for the day.
have to do something with this speaker that sounds like crap. But I think we know at this point that all of the major organs are good, and I could safely recap this thing without having to worry about doing all that work and then finding something major wrong with the radio. This grid, screen grid dropping resistor is supposed to be 1100 ohms. And this dual capacitor here, the section for the plate to grid coupling is supposed to be a 0.03, and the plate bypass capacitor for the first audio tube is supposed to be 0.001. So we'll go ahead and get those replaced with the proper parts here. Here's the old resistor, and as I expected it to be, it's one of those flex types, and these are bad about opening up here at the ends here. I think over time the connection gets corroded and it just breaks loose. And there's the new resistor down in there soldered and ready to go. Let's see if it does anything. Well,
ways to get out of it, and then you heard me tell you about Relief Factor. You know, heard about them on the radio, tried it. In about 2.5 weeks, I woke up one morning and realized that nagging lower back pain that I had had for a long time was suddenly gone.
I think this volume control may be a little iffy. It came on at high volume, and then whenever I turned it off and turned it back on, it straightened out.
All I ask is you give us 3 weeks to see if we can get you out of pain. Relief Factor.
Alright, there are those two capacitors replaced. Alright, 1 microfarad 160 volt versus a 1 microfarad 630 volt. You can see even the 630 volt modern day equivalent is smaller than the original, and that's not a value that I normally keep on hand. This is just one I happen to have from somewhere that I either cut out of something or something another, but the leads are too short, so we're going to have to add on some lead from this old part in order to make it fit in the chassis here. Very puny eye opening and very leaky, even at 50 volts. Okay, getting rid of that 1 microfarad leaky screen bypass cap, which of course one end connects to the screen supply and the other end connects to the heater, which is also the cathode of the tubes here. That got rid of some of that hum we had.
Those were just random 10 or 12 people that we picked. I kind of doubt it. Here's Peter in Farmington, Connecticut.
And me not really liking the J-hook parts, Crosley did a lot of that themselves in this radio. Crosley loved those dual section paper capacitors, and you can see what they did here. They just soldered the resistor onto this capacitor lead and then a piece of wire onto this capacitor lead running way over here to wherever. Looks like probably a plate bypass capacitor, most likely. And then we have this lead coming over here that goes back around to somewhere, to ground maybe. And then I believe the strap here is also the strap is a terminal. Because like I said, this has got 2 caps in one. I lifted this dual section capacitor out of the way and noticed this little one buried under there. So we might as well replace it while we have this one lifted. And if you notice, the other end of this little one runs from right here way on over here to the other side of the chassis. Now, what I've yet to determine, is there a resistor inside of that sleeving, or is that just strictly the lead off of the capacitor? Is there a resistor in series with that capacitor or not? And I suppose that's what we need to find out. Traced it back over here. Let's see what we have here. $60K and rising. So yeah, there apparently is a resistor there. Probably one of those flex jobs, and if it is, I'm going to go ahead and replace it before it has a chance to open on me. Like I told you, those are bad about opening up. Actually 5.3K, and as you can see, even Crosley extended the leads on new components to make them fit where they needed to go. Okay, here's our resistor, and I literally had to cut the sleeving off of it. It would not just simply slide out. Okay, violet, black, red, that should be 7K. It's reading 5.3K, so it's down a little bit. So yeah, body, N dot, body, violet, N black, and our red dot, that's our multiplier, that's 7K. And it is a bit outside of the 20% tolerance, so I'll just go ahead and replace it with a 6.8K ohm resistor, since this is such a pain in the butt to get to. Alright, here's our series resistor capacitor combination. As you can tell, all insulated up the 21st century way. There's no way this is going to short out to anything, and hopefully this will be long enough to extend from point A to point B. If it isn't, we'll just add another piece of wire up here. Okay, we're soldered in place. Here's this dual 1 microfarad solar seal tight, leaking like a sieve, as Mr. Carlson would say, seal tight to keep the leakage in. Although in all fairness, the later green cased seal tight capacitors, they seem to hold up better. I've actually ran into a few of them that were still usable, but I've also ran into a bunch of them that weren't, and even ran into one or two that were dead shorted. So if you find one, you probably should just go ahead and replace it. We now have these 3 capacitors replaced, and now would be a good time to run a performance check and make sure we're working at least as good as we were before we replace those 3 capacitors. Okay, it seems to be performing well. So we can proceed. Don't thank me, I'm turning you off. We had this Cornell Dublier capacitor that they were so generous to proudly put their name on, but they weren't as generous about putting the value of the capacitor on there, and the schematic is up in the house on the computer. I'm down here. I don't really want to run back up to the house right now. So I measured this on my handheld digital meter, and it read 0.7 something microfarad. And it also tests unbelievably leaky on the old school capacitor tester. So we know that a leaky capacitor will sometimes test as an overachiever on a modern digital meter, because when a capacitor is excessively leaky, it takes longer to charge, which fools the meter into thinking it's a larger capacitor than it really is. This appears to be just a cathode bypass cap for the first audio tube. So I just put a couple of 0.47s in parallel. That'll get us almost 1 microfarad. I don't think it's that critical. Probably better to go over than go under, so we're just going to stick that in there and see what happens. And right now 0.47 is the biggest value that I have in stock. I just used my last 1 microfarad to replace that big honking film capacitor just a little while ago. We have the capacitor replaced. The only difference, the original was grounded over here because it was a big honking capacitor that needed to be because of size restrictions. 90-year newer capacitors are not that big and honking, so we were able to ground the new one over here, and that saved us from having to extend the leads. Well, even had there not been a convenient ground tab here, I would have just sanded the chassis and soldered it directly to the chassis. We've certainly done that plenty of times. Now let's do a performance check and make sure we're still where we need to be. Okay, we appear to be where we were. That's a good thing. I think there's one more big honking capacitor to replace, and I don't think this is a dual one, thank goodness. Alright, the final one is a 0.25 at 200 volts. Not getting any kind of eye opening here, but I bet we're getting a lot of leakage. Oh yeah, even at the lowest voltage, it leaks like crazy. 0.25 at 200 volts, 0.22 at 630 volts. You can see the size difference there versus old versus new. Now that brings to mind a question I see brought up a lot on the various antique radio groups, and I've noticed it in some of the YouTube comments on various videos. The question will go something like, the capacitor in my radio is a 50 microfarad. Can I replace it with a 47 microfarad? Or the capacitor in my radio is a 0.05 microfarad. Can I replace it with a 0.047 microfarad, etc.? Or my capacitor is a 30 microfarad. Can I replace it with a 33 microfarad? Well, the answer to all of those questions is yes. The fact is, the tolerance levels on these older radios and other pieces of electronics is pretty wide, and a few microfarads either way is not going to matter when it comes to electrolytic filter capacitors, or 0.05, 0.047 versus 0.05. That's generally not going to make any difference whatsoever. In fact, in today's world, you can still get values like 0.05 and 50 microfarad, 30 microfarad capacitors, etc., etc., but they're getting hard to find, and they're more expensive, and don't let the people selling them fool you into thinking that it's going to make your old radio perform better. It's not. The newer values like 47 microfarad, 33 microfarad, 0.047, 0.15, 0.22, etc., etc., those are all these standard modern day values, and those will work fine in place of the older values. Basically, when replacing a capacitor, just replace it with one that is close to the original, with a working voltage that's rated at least that of the original, if not higher. Okay, that's good. Now, we need to do something about this speaker. Alright, whenever I hold my finger right there, it quiets down.
That's the deal. Okay, okay, let's get to, this was last night. The first pick.
I have the signal generator set to 456, which is the specified IF frequency. Why not 455? Because 455 was the RCA frequency. I think a lot of companies use different frequencies, such as 466, 470, etc., so they could get around paying royalties to RCA or patent rights or whatever. These tremors are adjusted by using a 1/4-inch tool. Technically, I need a non-conductive tool for this. I don't have one. I need to order one, but we'll try it with the nut driver here. Okay, that one was pretty much right on target. What about this one over here? That was a little off. And then I believe we have one back here. That was a little off too. This may not be perfect because using a metal tool can sometimes foul things up. Now we're going to radiate a signal into this at about 1500 and peek out these tremors on the tinning condenser, and then that'll take care of the alignment. Okay, we have 1500 about straight up on the dial. Let's adjust the oscillator section, which is the smallest of the three on the tinning condenser. That's pretty good. Now let's adjust these other two for maximum gain. Well, where did it fly off to? Take longer time to dig through the abyss to find that than it will just to get another screwdriver. That doesn't seem to be making much improvement. What about this one? Let's turn our output down some and see if I can That's probably about as good as this one's going to get. Shut up. Get in there. Okay, shut it down. Let's connect an antenna and see what we get. Yeah, this picks up the local stations, but this certainly is no DX magnet. But I think it's working about as good as it was ever capable of working.
That you need. Go to Denver, things don't pan out the
As you can hear with another speaker, which by the way has an output transformer attached, it sounds a lot better.
This is Fox Sports Radio, the premier sports lineup in the nation.
Are you ready to place a bet on today's games? Do fast authorizations on most withdrawals and gold standard customer service. Go to betrivers.com, see for in County, Indiana.
Although I think this chassis may need some more servicing done to it.
We've got replacement batteries that'll fit starting at just $69.99. You can learn more about our battery selection at AutoZone.com. That's what makes us.
I got off my lazy rear end and consulted the schematic, which is what I should have done in the first place. And that capacitor that was reading 0.7 is actually supposed to be a 0.5, and what I have in here amounts to almost 1 microfarad. So we're going to get that out, and we're going to go back with a 0.47 capacitor, and I'll just leave these two tied in parallel. Whenever I need a 1 microfarad film cap, then I'll have something all ready to go there. Well, I just deleted one of the capacitors. I was able to cut it out with still enough lead length on it for me to solder a lead to it, so I just deleted that one, and now we'll turn it on and see if our performance changes. Okay, that seems to have improved reception some, or maybe reception audio quality some. It doesn't appear to be as distorted now. And there's overpowered 1390 WMER. I metered all of the resistors, and most all of them check within their 20% plus or minus tolerance rating, so they'll stay. The only ones that I changed was that, of course, that open screen grid dropping resistor. And then the one that was in series with this capacitor, I changed it because it was a little out of tolerance, and I just changed this resistor coming off of the center terminal of the volume control. It's in the bias circuit. The original was 100K. It read a little over 150K. You know, that's not too terribly bad. In fact, it probably won't make any difference, but since it was a little bit out of the 20% range, I decided to go ahead and get rid of it.
Convince somebody.
I think it gets a little louder now.
I'm a different player now, and I'm willing to accept that because I just
Now, as we've talked about before with battery sets, these types are not going to have the tonal quality or the audio output power that an AC operated set will have. On a battery set, we're talking a maximum power output in the milliwatt range, whereas an AC powered set, you're probably going to be good for at least a watt, between a watt and 10 watts, depending on the quality of the radio and the type of audio output stage it has in it.
and regain some of its value on the market.
What do you make of Kyrie no showing at the Drew League?
Well, I still got one more weekend, and it's going here. But I would think Kyrie thing, he didn't want to go and be. But once he heard that LeBron was going, it's like, I'll have my own weekend.
We'll cover the cost.
Alright, I tried gluing this around here,
To help you get the coverage you need, we created a network of
and I actually
providers or
moistened this cone a little bit with some oil,
auto insurance agents,
and it's really not helping that much.
That means we trust them to serve.
The speaker really needs the attention of someone who is more familiar with speaker repair than I am, and I'm really not too worried about it, because this is not a radio I'm going to be playing on a regular basis. This is one I just wanted to resurrect, hear it play, and we've accomplished our mission. So, but I'm certainly not going to be listening to it with this horrible sounding speaker. Oh, and by the way, this speaker was made by Best Manufacturing Company. Now, the easiest way to solve this problem would be to simply replace the speaker with a 6-inch PM speaker with provisions for mounting an audio output transformer to it. But, I mean, I like this old speaker here. I just don't like the way it sounds, and I'd like to retain it if I can. So maybe one day I'll see about having it repaired, but that's not really on my list of priorities right now. What I'll probably end up doing for the time being is shoving some wadded up paper between the cone and the basket, and that'll sort of dampen the unwanted vibration there. It really sounds like a torn speaker cone, but I'm not finding any tears anywhere in it. Here's a warning on the power cable. Loosen but do not remove the chassis hold down screws before operating receiver. Make certain that chassis does not touch front panel after hold down screws have been loosened. Now, if you notice under here, these have rubber grommets on all 4 screws, and at one time there was some rubber strips under the chassis there. The idea was to loosen the screws just enough so that the chassis would be cushioned on the rubber strips but still be secure in the cabinet. And the reason for that was because these tubes that operate in battery receivers tend to be very microphonic, and the idea was to keep vibration to a minimum, thus keeping microphonics to a minimum. But the rubber strips that this chassis sat on have long since turned to powder. Okay, I just stuffed a paper towel in there, and that helps the problem tremendously. We can actually listen to this now.
Radio News Bureau. I'm Lance Prime.
Home builder sentiment is down sharply as fewer new homes are being sold. The National Association of Home Builders Housing Market Index plunged 12 points in July. High inflation and rising interest rates have dramatically slowed sales and buyer traffic. An economist with the group saying affordability is HARE 55 833 share 55. A man is in the running for a Woman of the Year award.
The University of Pennsylvania has nominated Leah Thomas, a man who is living as...
I think he wiped himself out, hitting 44 home runs, winning...
And we're getting a little hum in the speaker. I think that's just ripple from the power supply. A lot of these battery radios, some of them work okay on battery eliminators, some of them get pissed off. This one's kind of in between, I believe, but if we were running this off of battery power, we wouldn't be hearing any of that hum. Now, let's turn off the lights. It's really not late enough for any DX, but we'll see if anything comes in. Getting a lot of interference.
General Motors is standing by a pledge on electric vehicles. They would hold the biggest majority in it. Ballot this fall.
We will not, and the President has been clear, we will not let the filibuster stand in our way.
A lot of that noise could be from this power supply.
The filibuster is the Senate rule which requires
Phenomenal vehicle.
Last year, GM sold just 25,000 electric vehicles in the U.S., less than 1/10 of the estimated 352,000 sold by...
Maybe one day I'll rig up a battery pack for this thing, and we'll
small SUV.
run it on battery power just to see how it does.
Tesla's lowest priced vehicle sells for about $60,000. I'm Ed Donahue.
More details at SONnews.com. I'm Keith Peters reporting.
Stevens Funeral Home, 7774A, Highway 39 North, next door to Forest Lawn. He knows what to do, he knows what it feels like, and the pressures, and that there are many decisions that need...
I guess WMOX is falling down on the job again.
Killing that. Nice day. Compliments at WMER and Max Truck Service, 4915 5th Street, Meridian.
Happy Monday, everyone. There could still be a few showers this evening, so make sure to carry the umbrella if you have any dinner plans tonight. Otherwise, lows will bottom out to the low 70s, and it will remain a bit muggy. For your Tuesday, there could be some showers as we kick off the day, especially along and north of I-20. So again, some of us may start the day with a little wet weather. Otherwise, very hit-and-miss activity for the rest of the day. Hot, though, with those highs reaching the low to mid-90s. Feeling much hotter with the humidity. I'm Storm Team 11, Chief Meteorologist Theodore McKenzie for WMER, 93.1 FM, 1390 AM. Good news. Gospel Radio.
I'm Storm Team 11 Chief Meteorologist Theodore McKenzie. You've always trusted us to keep you informed about the weather.
Now these types of sets work best with an outdoor antenna and preferably an earth-ground connection. The better the antenna, the better the performance will be. With these older radios like this, antenna is everything. And my antenna is just about a 25 or 30 foot piece of wire running out the building with the other end tied to a bush outside.
SWAT Radio. Tune in weekdays from 2 to 3 p.m. You're listening to WMER on 93.1 FM and 1390 AM.
Carolina Panthers, Bears, the Jaguars, the Seahawks. Do it. Oh, that kind of
Oh, they're back.
So he's here to help me today, and we're going to talk to you about your life. The phone number is 888-825-5225. We'll start with Ben.
But yeah, as long as that speaker will sound reasonably okay with the paper towel stuffed in it, then
Better than I deserve. What's
probably just leave it alone.
Well, first of all, thanks for taking my call.
But I've looked over that speaker. I don't see any tears in it. I don't know why it would be rattling like that, but it is. But like I said, as long as the paper towel will quieten it down, then I'm fine with it.
As well. Obviously, we did the whole debt-to-income ratio. We wanted to be.
And over the years, I've had radios come to me with
comfortable.
wadded up paper towels and other material stuffed in between the cone and the basket
since December 21
to allow the speaker to be listenable.
I would just like to know what
do anything over 25%.
And another thing you may have noticed, I don't think I mentioned this previously in the video, is the absence of a dial light. Most AC radios from this time period, except the cheapest of them, had some sort of dial light. Most battery sets do not, because the presence of a dial bulb would be just that much more current draw on the A supply. And these things were big enough battery hogs as it was. They didn't need any extra load adding depleting the battery even faster. Now there were a few battery sets that had a dial light that was activated by a momentary switch. You just flip the switch to illuminate the dial long enough to tune in your station, then you let the switch go. And some of the 32 volt and 6 volt DC radios had dial bulbs, but usually the kind like this that runs off of an A battery, a couple of B batteries, and a C battery do not have dial lights.
Drive people into debt. They don't save to buy their next car, they go into debt to buy their next car. They don't save for Christmas, debt for all because they're house poor and they can't win.
This thing actually sounds pretty good for what it is.
It's virtually impossible to operate the household without going deeply into debt on the other items. There's just no room in your budget.
Heart of the Church of the Great I Am. Heart of the Church of the Great I Am.
All right.
He was leading the league in interceptions for most of the half of the year. You saw that start to fall. It just even here reports out of Dallas that they're going to start, Tony.
All right, that's about all I've got for the Crosley radio.
Back to what they're kind of were.
We successfully brought it back to life.
The team's heyday was like,
And we'll say goodbye for now, and more to come a little bit later.